I've returned from Morocco. Is it safe to go further than 5 meters from the bathroom? It sure is. Welcome back to Null Zero Labs, and in today's episode, we're jumping back into Palo Alto firewalls with high availability. Let's show you how it's done. And here we are in the lab. Bit empty today, but we've got the basics in place of the ISP has delivered a redundant gateway to us. So here's their two gateways with a redundant uplink to the internet. They've given us a public allocation of 192.0.2.0/24, and they have used the first 3 IP addresses of that allocation for the customer LAN side, and they have set up a VRRP address of the first address of 2.1. So that's going to be our default gateway address. So this is our redundant internet. So plugging a single firewall in kind of defeats the purpose. So today we're going to configure 2 Palo Altos in a highly redundant setup so that we can start the process of building out the redundant edge, and then we'll then connect it to our redundant LAN. So in today's video, we're going to concentrate just on the Palo Alto high availability configuration. So let's start by adding 2 Palo Alto nodes to our lab. So we're going to use 11.2.5. We want 2 of them, and we'll just call them PA, FW, and we need some more memory, or 8192, A192. Okay. Network interfaces. Obviously, you're going to need, and you have to include the management interface in this calculation. So here we got 4. So if we was to leave it as that, that would give us 3 interfaces and 1 management interface, which is not going to be enough. So we're going to go with 8. So we'll double it. So we'll have 7 interfaces for our use and 1 for the management interface, because obviously we're going to use 2 of those for our heartbeat and session interfaces for our HA1 and HA2. So we're going to change that to 8 ports. And that gives us our 2 firewalls. Now we're going to rename this so that there's something a bit more coherent. So FA1. And we want FW2. So these are our 2 firewalls that we have got. So first of all, we're going to need 2 connections for our HA. So let's use 7 to 7. And we will use 6 to 6. Okay. And then we know that our ISP, let me stop their gateways for the time being. Our ISP has told us that port 2 is for our use. So we're going to plug port 2 into our first port on our firewall. And we're going to do the same for the second one. So port 2 to our outside interface. So that gives us our basic connectivity to our ISP and our HA configuration. Next, we're going to need connection to our management network so that we can reach the web interface for doing configuration. So this switch here is connected to my network so that I will be able to add a tab up here and manage the interfaces, but we will set the IP addresses for those in a minute. So if we connect to the management interface on each device, that gives us management access to each of these. So that should be all of our physical connections for the time being that we require. So let's start up all of our pieces of hardware. Now, these 2 down here are going to take a little while to boot up on the first boot, but once they come up, we will connect. We will see the console interfaces. So let's connect to the console interfaces of firewall 1 and firewall 2. And they will go through their boot up process, and we will eventually get to a prompt that says PA hyphen or VM hyphen FW. Once we reach that stage, we'll be ready to log in. So we'll be back in a minute once these boot up. Subsequent boots are a bit quicker. There we go, and we're able to log in now. I logged in with admin, and we're now going to change that password. You get prompted to change it on the first boot. So admin, we'll set a super secure password and confirm it. Now the management network does have DHCP running, but it will, what I will do is we'll go through setting it statically, and we'll go from there. So we're going to go into configure mode, and we want to set the management interface so that we can get into the web interface to start setting up our firewalls. So from here, we're going to go set a device config system type. We're going to set it to static. And then we're going to set the IP address to 192.168.68. I'm going to use 243. The net mask will be 255.255.255.0. And I'm not going to set a gateway because I don't need one. So that should be that for that. I'm going to commit that. We'll jump over onto our second one. If it's booted up, admin. Yes, it has. So admin is the old password. Set our new password. Something a bit more complex. Oh. Okay, let's try again. Getting used to this new keyboard. Old password is admin. New password. Okay, it's better. Now we do the same. We're going to config mode. We're going to set the device config system type as static. And we will set the management IP address of 192.168.68.244. Use 243 for that one, 244 for this one. Net mask will be 255.255.255.0, and I won't bother with a gateway. And we will hit commit even. Right, so that one is committing. This one has committed and is successful. And then let's wait for this one, and we should be able to see the second one as well. And we want to go to 244. There we go. So we've got both of our firewalls. So let's start with our active, our primary one. So admin, our super secret password. Nope, go away. Right, there we go. We're not interested in the pop-ups. We are going to turn off the telemetry. Not going to be using that. So our first job and operations is to go to, let's just double check management. So let's set ourselves our host name. So this is PA-FW1. We'll set our time zone as Europe, London. There we go. Click on OK. So we've got our name, our time zone is set, and we've got our time and date. So that's fine. We've turned off telemetry. So we're all good there. Let's jump to our network side. And we did say that 1/6 and 1/7 are going to be designated for our heartbeat or high availability. So let's convert those. So that's that. And if we jump into our HA configuration, we're going to enable, and this is, we'll use group ID of 10. The mode is active and passive, and the peer address, because we're going to assign. So we're going to use 10.21.1.2 is going to be our peer. So that's going to be our passive node. That's who we're going to be talking to. Our active and passive settings are going to be auto. This speeds up convergence. So we'll set that to auto. And then our elections, as this is going to be our primary one, we'll set that as 80, and we'll go with the recommended settings there. So next we're going to configure our HA communications. So we're going to use 1/6 as our HA1 interface, and that's going to be 10.21.1.1, 255.255.255.0. And our HA2 interface is going to be on port 1/7. We don't need a IP address, and it will do keep alive as well. So that should be everything to get the basic configuration done on one. So we will commit that. We will jump, whilst that's committing, let's jump over to our second one. Just going to lock that so it stops asking me. Right, so same again. Let's turn off any telemetry. We don't need it, so we will turn that off for now. Again, we jump over to management. We're going to set this as PA-FW2. Again, it's going to be in Europe and London. There we go. Set the time, yada yada. So the time is set and the layer banner is set. Next, we're going to go over to network, and we're going to say that 1 and 6 are high availability interfaces, not being used for any other purpose. 6 and 7 are HA. And then we can jump to our high availability setup. So this one, we're going to enable it. And I think we said we were group 10. If I'm remembering right. Yep, group ID is 10. So group ID is 10. Active passive. Our peer address is going to be 10.21.1.1 because that's the node we're talking to over here. Again, our passive and link state for our backup interface would be in auto. And this one is going to be a higher priority of 100, and our other one is 80. So this is designated as the secondary, and we will use our recommended profile. HA communication. Our control link is on 1/6. Our IP address is 10.21.1.2. No gateway because they're back-to-back connected. And our HA2 data link is on port 7, and it also does keep alive. And again, because we're using the transport of Ethernet, we don't need to specify any IP address. If you was doing this over a routed connection, you'd obviously want to change it to IP. So if we commit this, We'll let that go through. We'll jump back over to our primary one and come back over to the dashboard. Now, if we go to widgets, we can turn on HA, and we can see at the moment that everything is in an unknown state. Once the secondary commit has gone through, we should see these all turn green, and we should see it ready for us to do our initial configuration synchronization. And what we should see is that we are the local active and our peer should be the passive. And there we go. We can see that the synchronization or the config save on the secondary one is now complete. Let's go to widgets on here, turn on HA. So we can see that this secondary device is in passive mode. The active one is the other peer, this one over here, the one that's in active. And we can see that the configuration has not yet been synchronized between the two, but everything else all matches. So let's jump over to our primary one. Let's just sync, do an initial configuration sync, and then we will be ready to continue. So at the moment, we've now configured these two interfaces here as our control link, and which is also doing our HA heartbeat connection. And then we've got our data link, which is doing the sessions and also doing heartbeat as well, because we turned that on. So we have our two connections to maintain this cluster here. And our management interfaces are what we're using to manage the firewalls. So once we've completed this, our next stage is going to be, we'll be working on firewall 1. We'll configure just the outside interface, a route, and then we will then configure the port monitoring and route monitoring to the ISP's gateway, so that we can also fail over not only if this device was to die and this one would then take over, but if, say, someone unplugged this cable or if this cable broke, we'd also want to fail over to the second one because this device can no longer reach the internet. So what we've configured so far gets us just to device HA. So if I was to switch this device off, this one would see it and become the active and would carry on working. But if I was to unplug this cable right now, or if I was to turn off this router of the ISP, this one would still be the primary. It wouldn't force a failover. So that's what we'll do last. So back over to network. We know our external is going to be on ETH1. It's going to be a layer 3 interface. It's going to be part of our default virtual router. And we're going to create a new security zone called outside, just for simplicity. So outside, and we're going to give it an IP address. One thing you'll notice here for the ISP, they've used 3 of our public IP addresses to create the redundancy. We only need to use 1 public IP address on the interface here, as it will fail over and move between the 2. So the next available one will be 2.4. We use 192.0.2.4/24. Under our advanced, we'll just set a management profile of ping only, just so that we can test that we can reach the outside interface. And that should be all we need to enable that. So we'll hit OK. Next, we'll need our default route. Under our virtual route, under default, static route, we're going to add a new one called default. And this is going to be 0.0.0.0/0. So internet. It's going to go out of our outside interface, and the next hop IP address is 192.0.2.1, which is the VRRP address of the ISP's equipment. We will click on OK. So what we should see happen now is that we're going to save the configuration of this interface that we've configured in the default route on firewall 1. Once we commit it, we should see it synchronized to firewall 2, and you'll see that firewall 2 will have an outside interface with the same IP address that we configured, but obviously it won't be in an active state, so it won't interfere with network communication. All of the traffic for that IP address will come here. So we will check back once this is completed. Cool, we have successfully completed, so we'll close. So we have our default route and we have a public WAN interface configured. We come over to the second one. We have a look at the network. We can see that it too has got the same IP address for the outside interface. It's obviously still synchronizing because it's link state. It's still in a down state. Synchronization in progress. So the commit happened on the primary. Everything's synchronizing over to the secondary. There we go. Oh, wrong one. Let's hit refresh again. There we go. We can see it's synchronized. Now we come over here. We can see it's got the exact same configuration. So at the moment, from the internet side, if we was to ping that public IP address, the traffic will come here. If we was to switch this device off, this one would take over and the public IP address of 192.0.2.4 would become active on this firewall 2's interface, and traffic would then take this path into the firewall. Now we want to configure if someone wants to cut this cable, or if it couldn't ping the gateway address, that we want to fail over to this one. So what we're going to do now is on the primary one, we want high availability again. Link monitoring is enabled and path monitoring is enabled. So we're going to add the interface that we want to monitor, which is going to be our WAN interface. So we want to monitor that interface. And then we want to add a virtual path using the default router. Can you reach the ISP gateway? It should be 192.0.2.1. Commit that, because we're going to have to configure the same thing on the secondary one. So we'll be back after the commit. Okay, so that's committed. So we can see what we've got now is two types of link monitoring. We're monitoring the interface. So if it fails in any way, that interface goes down, we will fail over. If the path to the ISP's gateway, because sometimes, because this is a Ethernet connection, you might see that you've got an Ethernet connection from device A to device B, but there may be a failure, but electrically the interface may stay up. So what we're doing here is we're monitoring a path, so that we've got to be able to get a response back from the IP level to say that, yeah, I can reach that. And if you can reach that, then everything's all good. So now we can go back to our dashboard. We see that this device is still the active and the other one's the passive. Let's jump over to the firewall 2. And we're going to do the same on the secondary one. We want to monitor the WAN interface. So we'll call it WAN. It's on ETH1. We'll click on OK. And then we're going to add a path via the default router. And we need to check that we've got reachability to the ISP gateway. which is 192.0.2.1. And we will click apply and we will commit on this side. So what we can do whilst that's committing, if we have a look at this connection here, if we say take a look at ISP1 and we right click, we do a capture on the customer facing interface, which is G0/2, and we feed that into Wireshark, we can see that we are getting, this is our test ping that is coming from our path monitoring. So it's going from 192.0.2.4 testing to the ISP gateway address of 192.0.2.1. So if I stop that so we don't see it moving, you can see that we are testing that we can reach from the WAN interface to the ISP's interface. So that checks and makes sure that that interface is up and responding. So we're getting a request and we're getting a reply. Good. We shouldn't see that happening from this interface because at the moment, even though we've configured it, the IP address on here will not be active at the same time as the other active device because it's in a passive state. So all that's going to happen there is that if this device ever becomes the active, then that same path and link monitoring will start taking effect. So we can just double check that. If we just capture on here, G0/2, we may see it because it's in a VLAN, but we'll see it coming from the same. No, all we're seeing here is the HSRP data showing that it's in a standby state, which is correct. Perfect. Quit without saving. So what we'll do is if we test, we can now test by, if we were to drop the IP, shut down the interface for G0/2, we should see that this will fail and we should see that this one becomes the active. So let's test that. Now we're going in G0/2 and I'm going to shut that. Okay, so there we can see that this device, the primary device, is now non-functional because the device can't reach any destination that we're monitoring. So there's no point in it even being standby. So it's now gone into a non-functional state, and this one over here, the secondary one, has now become the active firewall. Now, if we do that same test again, and we come over here and we capture on the customer facing interface, there we go. We can see, stop that. So stop scrolling past. We can see our public IP address of 2.4, which is now active on the secondary firewall, is now testing the path to the ISP gateway, and it is now the active firewall. So let's put ourselves back in the state that we were in. Let's bring this interface back up. So this interface is now back online. Let's refresh firewall 1. We should see that it's able to reach the destination again. There we go. We can see it's now in the passive state, and the other peer is now the primary. If we wanted the firewall 1 to always come back as the primary, we would need to turn on the preempt. So we can go into our device and we can then come over here to our general, and we can turn this on here to make sure that this low end one always becomes the primary again. So if I commit that, okay, that is now successfully committed. And let's set the same on the secondary one. So this one has got a higher number, which means it's the lower priority, but you have to enable it on both devices for this to work. So we'll hit commit. You'll find that most of the time some of the configuration options under the high availability section, you have to configure independently on both devices, but the rest of the configuration like interfaces, authentication settings, DHCP scopes will all be synchronized between the two. So once this commit goes through on the secondary one, if we go back over to firewall 1, we should see that it will migrate itself back to being the active, and the secondary one will migrate back to being the primary. So the next test once this happens, we'll do another test where we will completely switch off firewall 1, and we should see firewall 2 become the active again, and then we'll bring firewall 1 back up online, and we should see it change back over to firewall 1 being the active, and then we can then test switching off firewall 2. So that is done on both sides. So now we wait for the timers. And there we go, on firewall 2, it has now changed and become the passive, and firewall 1 has become the active. And if we jump over to firewall 1 and hit refresh, we can see that the local firewall 1 is now active and firewall 2 is now passive. So if you want to always know for sure that one of these firewalls is always going to be the master, you can enable that feature so that you can always guarantee that firewall 1 is your master firewall. It's kind of useful, I suppose, but like in the grand scheme of things, if you have two of them configured in active and passive, it kind of, and they're both going into the same ISP and they're using the same public IP, it kind of really doesn't really matter too much which one is the active or the passive. You've kind of just got to remember that you want to try and do your configuration steps mainly on the primary device, and then synchronize across to the secondary so you don't end up with any kind of synchronization issues. So at the moment we've configured HA, and we've got our WAN interface configured, and we've got reachability from our WAN interface to the ISP's gateways. We've done a failover test by terminating the actual physical interface of the device, and firewall 2 took over. Then when firewall 1 had reachability again back to the gateway, firewall 1 then reverted back to being the master. So now let's test if we was to shut down firewall 1, we should see firewall 2 take over. Now we could log on to firewall 1. We can go to device, under setup, operations, we can reboot the device or shut it down. So let's do a non-clean, because that might be more of the scenario. A clean scenario would be when you do an upgrade and it would automatically change over. For us, let's say someone pulled the power out. So we'll stop firewall 1, jump over to firewall 2. We can see it's missed. We can see that, there we go, happened that quickly, that the local device of firewall 2 is now the active. Everything's functional. We can see that everything else has gone into an unknown state and the interfaces have gone down. Now, if we bring firewall 1 back online, we'll let that boot back up. And then what we should see is that once firewall 1 is back online, we will see that it will take back over again as the active, and all of the software versions and running configuration should go back into a green state, and the HA1 and HA2 interface should be green again. All right, and we can see that firewall 1 has just made it back online. The firewall 2 is still the active at the moment. Let's log into firewall 1. We wait a little bit and we hit refresh. We should see firewall 1 retain the role of active. And there we go. Firewall 1 has now resumed the job of active. Firewall 2 is now the passive again. So there we go. We have got full redundancy between our Palo Altos and our internet connection. In the next video, we'll add our Nexus pair below in a VPC configuration, and we will configure an LACP connection from each of these firewalls to the Nexus switches, and we will configure the best practices there to configure the high availability on the Palo Alto for that connection, and the path and link monitoring, so that again, if one of the connections to the switches was to go down, we can move over onto one of our other firewalls. And that's it for this video. Thank you very much for watching. Please remember to like and subscribe. It really helps the channel grow. The more of you that hit that like button and hit that subscribe button, it lets me know I'm doing something right. In the next video, we will add onto this lab by adding the internal LAN side of the configuration, like I said, and we will set up the best practice for that side of the configuration. And again, we will run through some failover scenarios. So look out for that video, and I will see you in the next one. Bye-bye.